Hello friends, how are you? So welcome to Code Creators YouTube channel. And today I am going to explain these problems. Most important interview perspective से हैं और this problem last problem actually this is very easy problem. That's why I included here because I have already explained you different type of traversals. This can be solved easily. Okay, I don't have to means solve into system. And this is balanced binary and children sum property, most important two problem actually. So I can complete this last one actually. So max width actually, you have to find out the max width in binary tree. Okay, in binary tree, in binary tree. ठीक. So let's see, you have given some tree like that. This is binary tree. Okay, so you have to find out the maximum width of binary. So maximum width, what is the maximum width means? Width, this way we can calculate here. Okay. So means for each level you can calculate the number of node. For each level you can calculate the number of nodes. And which level have maximum node? So you can return that answer. So this is zeroth level, first level, second level, and third level, and this is fourth level. Okay, let's so let's one add one more node here. This is very simple because of I have already explained level order traversal different way. Level order traversal in different way. So if you means while doing level order traversal, you can calculate. Me I had explained through null pointer and other way. Null pointer using by adding null and other I had explained using means by iterating through loop. Okay, so means every for each level you null pointer means in the queue you will insert null to identify that this level has been completed. Okay, and other way means for each level you can directly use a loop for loop and you can print every element in particular loop. Okay, that's way. So means while doing a level order to version you can count the size number of element into particular elements into number of elements into queue. So you can calculate size here, size, and you can keep updating the size for every level. Max, so just this is just as a finding the maximum value in from the array because you have queue you have already. Okay, this is queue. You have a q variable and you can take here max something max variable in the top, max is equal to something like minus 999 that way, and you can and here you will get the size of the queue. Size is equal to size. Okay, and you can check every time while doing inserting left right of node of the tree, and you can calculate if size greater than max, so you can update the max here. A different way you can use the max method of math class simply. So that's why it is very simple. Okay, let's go to the other problem. This is children sum property. This is most important. So children some property means you if because I am working on here currently binary. So binary means for any node you can have maximum of two node a child only. Okay, so it means for the child, if my root node having some value like I can assume here. Okay, let's say I have here 50, okay, or 60. If this node having 60 value, so it means child in child sum property doing sum of these child's node values, if it is equal of parent value, so it means it's following the children sum property. So it means means how many combination we can make here, any of them like 30 30 I can put here in the child or something else. So let's put here 4, right, yeah, left I have multiple, okay, left let's put here 40 here and 20. So this means till this level this tree actually following the children's some property, because of that these childs, if I'm doing some of the child's data, it's equal to parent data, parent node data, okay. That's why it's following the child property. Here if I add here some values like for this I can add here 10, and here I can add here 30. It's mean here also 10, 30, and here if value is same, you are inserting if you value here 20 only, that means you are following the then only we can follow the children's sum property, because of right node having null value. Okay, right node having null address only, it means I can't that means for the null we have 0 only, we have only 0. So for the left we should have total 20 value only. Then only we can say it's follow children sum property. And sometimes like here 10, because I have single node only, so it should have 10 only. And here because of 30, so I can add here 10 and 20 this way, 10, 20, and here I have 20. It means single node only 20 only, and here I can add 5 and 15 this way. Other this tree actually following the children's sum property. For another tree, if I say here I have 25, and here I have 10, here I have 20. So this tree actually not following the children's sum property. So this you have to find out. Okay, you have to return boolean either true or false. True means this tree following the children's sum property. False means tree particular tree is not following the children's sum property. Okay, so how I can solve this problem? Because of you have to like visit the every node once. So sure we can use any of the traversal. Okay, a recursive approach will be better here. So I think I should, okay, right here only, or I can remove this. No, I don't want remove actually. So I'm writing here because code might be little bit long. So I'm creating a function. You have to return some boolean. Okay, boolean true or false, and you have some function with node root. Okay, so here you have to add some base condition. Base condition is most important here because lot of people couldn't understand what should I add here base condition. So Actually, I was also confused here, but I am telling you here how what is the base condition for this here. If root equal to null, then you have to return true. Okay, return true मीन्स अगर अगर ये जो नोड है कोई नल पास किया जाता है फंक्शन मेथड कोई कॉल करता है विद नल वैल्यू देन यू हैव टू रिटर्न ट्रू कि ये चिल्ड्रन सम प्रॉपर्टी को फॉलो कर रहा है ओके इफ नोड अगर इफ आई थिंक इधर से लगाना चाहिए था मुझे कोई नहीं इफ अगर कोई रूट इफ रूट हैविंग लेफ्ट रूट लेफ्ट चाइल्ड root left child okay left child equal to null and means root right child also null left and right both means childs are null it means someone passing the tree just like this having value some 15 it also means like it's following children some property why if you see here while we are having here null. Ideally, we should return here false, but you should not return false. Okay. Why I'm saying ideally because of here you should I think what I think here you should assume here because of left child is null, so you should assume zero. That's zero rights because right is null, so assume zero. And if lot of people misunderstand this way only, that's why means making some mistake. Otherwise, this problem also very easy to solve. I'll tell you. So that's why means that if you return false, you can't solve the problem actually. Okay. So returning here, I have to return here true. True. And other now what I have to think here now after base condition because of here if you can calculate if you could means uh, if you could verify this in first root only means every by iterating like this is I think I can assume like traversal like pre-order traversal just like pre-order in the pre-order traversal what we will do mostly printing the node first then iterating left then iterating right this way only you can assume here I am verifying in the first verifying first like this either this child this node following this node following children some property or not because in the first stage in the recursion first stage actually I am in this node okay I am at this node so if I could verify this one so this level has been completed means this level has been completed now is in the second iteration second recursive iteration means you will come to this place so if you could verify this node also either it's following children some property or not so it means I have completed this level and I have completed this level means if you could verify this and this both okay if you had verified this one you had verified this one also like if it is following children some property this also following children some property this also following children some property means it's verified means I am doing first this verification type okay first I'm doing verification then later on I'm doing left and right a recursive call this is like a pre-order traversal only pre-order traversal what I'll do is mostly I'll do print first then I'll do left call function left and function right this way we used to do in pre-order traversal mostly okay First, we means we would do print. Then we mostly used to do fun left recursive call. Then used to do like right recursive call. So here also what I'll do here, first instead of print, because of I'm doing here children some property, I have to do children some property. In children some property means I have to verify either this particular level or this particular node either following children some property or not following. So it means I have to write here this place. I have to write some code to verify. So how I can means verify this one? I should take here some variable int like sum, because of for left child and right side I have to take a sum. Then only I could compare with the root node data. Okay. So sum I have taken here. First, this is 0, and I'm removing actually here. And then what I have to do? I have to add left. So if check if root dot left not equal to null. Okay, root dot left not equal to null. अगर left null नहीं है तो it means I can add into sum plus is equal to sum plus is equal to root dot left dot data. Okay, left का data means this 14 I have added here in the sum, and now I have to add 20 also. So again put a condition root dot right, if not null तो sum ऐड कर सकते हैं. In the beginning I have sum 0 only, and and now in this stage I have added 40 because of 40 over exist. Okay, 40 were exists in the left side of the root node. That's why I've added into 14 into sum, means sum now in this stage some value is 14 only. And while I'm checking writing other condition, right, if right also not equal to null, then only you could means add into sum. So sum plus is equal to root dot right dot data. Okay, it means I have now I have calculated my child sum only. So this second stage, what is the second stage now? Second stage my to compare either it's equal to root node or not. So this could be done into different way, and this could also, okay, this could also done into different way, like you can do into one condition, like if root dot left not equal to null and right is equal to null, then you can add but that will be large, means condition will be very large. So this is simple way to calculate. Now second step, my second step to calculate the, like I have to take a boolean, some boolean variable flag type. Okay, flag is equal to if sum double equal to root dot data, if सम डबल इक्वल टू रूट डॉट डाटा, अगर रूट का डाटा अगर ठीक है, सम डबल इक्वल रूट डॉट डाटा, you have to add some bracket also. So it means I have some flag, true or false, means first level I have done. For the first level I have done. Now I have to same thing I have to do for left child and right child also. Okay, so it means for the first level only first root node I have done, but I have to same things I have to do for the left child, for the right child also. So what it means, I have to call for left recursive and for the right recursive call. And अगर लेफ्ट रिकर्सिव कॉल भी रिटर्न करता है ट्रू ही, ठीक, इफ दिस लेफ्ट बिकॉज ऑफ आई हैव डन फॉर दिस वन एंड नाउ आई हैव टू डू फॉर दिस वन। अगर ये भी रिटर्न ट्रू करता है, लेट्स से ये भी रिटर्न यहाँ से रिटर्न ये ट्रू करता है, तो इस इट मीन्स दिस is, if this is the true and this also true, then only I can return true, otherwise I can return true. Otherwise any of these condition, if any of these condition had been agar failed, so it means I have to return false only, for a complete result will be false only. So here, if let's say assume this condition has been failed, okay, so it means this will return, like assume here I had 10 only, so 10 it is not equal to 30, it means here I have false, so this will return false, but here I had actually, here I had true, so this, okay, here in at this place I have true because of 30 and 10 is true only, but here from as of because of from this child's adding some of this child's, it's not equal to 30 means this is false and this is true, this is false and this is true. So by I have to do here end condition. If this condition is true and this true, then only I'll return true here, otherwise I'll return false, if because if any of them is false. Okay, any of them, like 10, if 10 is false and or 30 is false, because in this case 30 is false because of 30 root node, it doesn't have actually is equal to sum of child's data. Okay, so that's why if the means what I have to do here, and if left is true and right is true, left is true and right is true, then only a little complete true. Okay, so it means you have to do, this is flag for left, and you can make actually directly make, you can make directly call here, return if flag is true. Okay, flag is true, flag is true, and function root dot left, root dot left, if this also true, this function call return true, and function root dot right, and right function also returning true, then only I'll return complete true. This is the proper solution, okay, to find out the, to evaluate the children sum property. Okay, so let's do some um, manual iteration, dry and run type something, so we could understand. So let's take this only. Okay, so at the beginning I had 16, then because of it's not null, not null, it means comes to here left sum, right sum, it's become 20, 40, 20, 60 only. So I have 60. 60 is equal to actually is equal to 60 root data. So I have some flag, and in the beginning, in the base case, I have actually here I have true. Okay, and now calling to left call, and I'll make here some simple. Okay. Now calling to left call. Left for the left call means left for the left child I'm doing here. Left child means 14. For the 14 I'll calculate here. For 14 I'll calculate here. Here 10 and 13. 10 and 13. And for the left call I'll make another function call. Okay. fun here. I'll do another function call. Okay, so here if you check here, because of in this case here I have 10 and 13, it's also actually equal to 14, it means true. Left function call also return, here also I have true, but I'll make here again left call. left recursive call. Okay, function. For the 14, I'll do a check here from the I comes to here 10th node. For the 10, if you calculate left right, so left having 10 and equal to 10 only, so it means true. It will return true only. So return, I'll put here T only. Okay, T and make a left call. Left call because of null. It is null means return true only. So left also comes here true. Okay, it means it's also left also true, and because of 10th right node also null, and this will also return true only. Okay, so and T. So this true and this true. It means all the true and all the values are true in end condition. Okay, it means complete condition is true. So this will return true here. Okay, it means this also becomes true now, and while I was returning, एंड एक्चुअली मैंने यहाँ पे वैल्यू नहीं पुट किया अदर, क्योंकि यहाँ पे भूल भी सकता हूँ मैं. तो लेट्स एज्यूम फॉर द रूट, while I was doing for root node, this was for 16. Okay, 16. I should some value also, otherwise I'll forget. And that was for 14. Second one was for 14, and third one was for 10th. Okay, this way. So now I came to here 14th node. Because of 14th I completed here left, because this is true, and I have to calculate for right also. So for right means for 13 you make another recursive call for 13 function. Okay, I'll put here 13 directly, 30. So for 30, if you do left and right, because of left having 10, right having also 10, not 20. Okay, assume 10 only. Left 10, right 10. So by this calculation actually flag will be false, because of left 10, right 10, 20, it's not equal to root dot data. Root, what is the root value is 13. So it means this flag will be false for this case. Okay, and now call for left child. Left child means 10, and right I have 10 also again. So for 10, if you call here left child means function, you will do here some 10th. Because of 10th left and right of all true, all null, it means this will return actually true only. So you can put here true. Okay, and for right also, because having 10 value only, this same function return and return true only. So this true, but this is false. It means it will make, because of this false actually it makes whole statement, whole condition false. So it means this will return false only. 30, from where I had called from this place. So here I returned actually false, f. I can put here f instead of false. So let's come up little bit. Here I have false, this is true, this is true, but due to this false actually it make whole condition false only. So 40 will return here false. और एक चीज़ मैं कर सकता हूँ यहाँ पे, अगर कहीं से फॉल्स रिटर्न हो जाता है तो राइट को फिर चेक करने की भी कोई ज़रूरत नहीं. देयर इज नो यूज ऑफ कॉलिंग टू राइट. You can make some optimization also, but here I had not made any optimization, because of it returns false only. And in at this place 16, left will return false. Left, what it will return false, but and you have to still call for the right. You have to still call for the right child. Right child, what is right child for 16? This 20. You have to calculate it again for the right whole tree. But if you made some optimization here, if flag comes false, you should not call left or right anything. You should return completely false, because of, if you found any condition false, it means this tree is not following this children some property. Okay, so this way you can make some little bit optimization also. Okay, so you don't have to visit every node in the tree. So I think this is done. And now comes to binary tree. I don't think I have should write code into id, because I have written everything here, okay, properly. So you can copy code from here only. Otherwise, I'll put code in description box, because I wanted to explain this balance tree also actually in this lecture. Because I in the tree section, if you see, lot of problems we have, and I wanted to mm, I wanted to actually complete as much as possible I could. So let's here work for balance tree. So in the balance tree means, if you have some tree, देखो बैलेंस ट्री में सिंपल सी बात है कि यहाँ पे ट्री हमारी, हम पहले भी आई थिंक आई हैव डिस्कस्ड ऑलरेडी फॉर द बैलेंस ट्री. बैलेंस ट्री मीन्स लेफ्ट चाइल्ड, लेफ्ट एंड राइट चाइल्ड, इनका जो लेवल है अप्रॉक्स सेम होना चाहिए. अप्रॉक्स सेम मैं कह रहा हूँ, एकदम से कंप्लीट बाइनरी ट्री की बात नहीं कर रहा हूँ. कंप्लीट बाइनरी ट्री, फुल बाइनरी ट्री एंड अदर बाइनरी ट्री. एक और बाइनरी ट्री थी, कौन सी? एक और बाइनरी ट्री थी, मुझे याद नहीं आ रहा है. जिसमें कि सारे फुल कंप्लीट नोड होते हैं, सभी में से पूरी ट्री में कंप्लीट नोड होते हैं. कंप्लीट नोड मतलब यहाँ पे सारे एवरी नोड हैविंग टू चाइल्ड ओनली, जीरो और टू. जीरो और टू, मैं भूल गया, बट आप देख सकते हो थ्योरी में मैंने स्टार्ट में बताया था, जीरो और टू. ठीक. इन द कंप्लीट बाइनरी में क्या होता है? कंप्लीट बाइनरी में आप एवरी नोड हैविंग, श्योरली एवरी नोड हैविंग आइदर जीरो नोड और टू नोड, जीरो और टू. बट एक्सेप्शन केस है, in the last level you could have actually, in the last level you could have all the node into left side only. मीन्स अगर आपके पास में कंप्लीट नोड नहीं है, तो लास्ट लेवल में आपके जो भी नोड होंगे वो लेफ्ट साइड में होंगे. इस तरीके से आप रख सकते हो. ठीक है, तो ये भी कंप्लीट माइनॉरिटी हम इसको कह सकते हैं. ठीक है, थ्योरी बेस पे नहीं जाते हैं हम लोग, चलते हैं डायरेक्टली अपना जो प्रॉब्लम है बैलेंस बाइनरी में. सो बैलेंस बाइनरी मीन्स we have to calculate height. और height I actually I have already done. So यहाँ पे अगर आप देखोगे, if you see here, left height of the any node, left height of any node and right height of the any node, if these difference means I have some left height, okay, I have some left height and I have some right height. So if these difference, left height difference and right height difference, if this difference actually is greater than जीरो, greater than वन, अगर वन से ज़्यादा डिफरेंस हो जाता है तो देन इट मीन्स दिस इज नॉट बैलेंस ट्री. ओके, इट मीन्स दिस इज नॉट बैलेंस ट्री. बट ये दिस कंडीशन यू हैव टू चेक एवरीथिंग एवरीवेयर. लेट्स आई हैव another another tree this way. If you talk about this tree, you have to check either this is balanced or not. Okay, and other I can make another example like here I have, and here I have this way. This way, this tree I'll check here either this tree is balanced or not. Okay, so only you have to check this condition only for this tree. I if in nav approach in the nav approach, what you could do here in the nav approach, simply find out the height of this node and find out the left child height and right child height. Okay, so इसकी हाइट अगर आप देखोगे तो इसकी हाइट आ रही कितनी, 3 आ रही. And for this node if you see here, this also having 3 only, this also having 3 only, 1 2 3. It means these are same only, there is no issue. But if you see if you see for this node, left right a 1 1 only, there is no issue. And for this node also you have to check this node, this left having one node and right having 0. And for this I think height will be 2 only, not 3. Let's assume 2 only. Okay, so here if you see your left child, no, 0, from the right 0 and from the left 1, 1 minus 0 1 only. It's not greater than 1, actually it's equal to 1. Here 0, there is no issue. So here from 0 and 1, from here I have 0, a left side having 0 and right side having 1 height. It means this is also actually difference. If you calculate here, this is not greater than 1. It means it is true. और यहाँ पे जो रिटर्न करेंगे हाइट ऊपर की ओर, तो इसमें +1 करके रिटर्न करेंगे. एवरी टाइम आई विल रिटर्न बाय डूइंग +1. तो यहाँ पे भी इफ यू सी, but nav approach actually recently, sorry, I am doing it for nav approach only. Means in every level for each node I'll calculate the height and I'll check either it's following the this condition or not, and that way I'll return true or false. This is nav approach. Okay, what you will do here, you will call the you have some function, some having root. Okay, node, and you will call left height root dot left left, and right height you have some h right height root dot right. This way in the nav approach you'll do, and I have to calculate the absolute value. Okay, so let's check here. Diff some diff variable I have is equal to abs lh minus rh, lh minus rh. Or then if, and here also you can do some optimization, otherwise you can call left or right simply. You could also here return def, and you could also I think what if it is here only I can put condition. If it's greater, then if it's greater than, check I should check, or greater than or less equal to. For the true I have to check less equal to. For the false, for the true only, for the true only I would like to less equal to 1. Okay, if it's less equal to 1 means if it is true. So if it is not def now, here I have some flag. Same way means as in the previous condition, previous problem I did. Same way here also you could do. So flag and left call and right. देखा ना कितना सिंपल सा है। तो इस तरीके से आप इसको कर सकते हो। क्यों? आई हैव चेक्ड हियर, क्योंकि हम प्रत्येक लेवल पे यहाँ पे चेक करें। फॉर एवरी लेवल आई एम डूइंग लेफ्ट हाइट एंड राइट हाइट। Okay, that's why. If for this route actually, I you means while doing here for left height actually, for this node I have to calculate the height. Means have previous code whatever I written for to find out the height. This you that only you have to call for the calculation. It means this will I again means visit every node in the left in this tree. You can assume this is the tree line root only. Okay, this assume for right child also you can assume this is root. And while doing height calculation, it will visit, this function will visit actually every node in this tree. Okay, that's way I can do. So let's see here. This is actually either this is balanced or not. So this is actually balanced because of here I have seen here but from this place if you see, so left right both are two having two. So it means this left right having true means for this will return less equal to 1, because difference is 0, so it's surely it's less equal to 1 only. So it means it is this flag is comes true. So I can make here flag. Okay, I can, I think, do some manual dry and run manual iteration type. So just assume here I had function, because I had not written actually some any values actually. So I have to put 1 2 3 4 5 6 7 8 and 9. So let's I had some one root node in the beginning, and I have calculated left right height both are less equal. Condition is true means I have some true and calling for left. So left के लिए अगर कॉल करोगे तो left means यहाँ पे आ जाओगे. So you will call for function for two node, और two के लिए then you have to check same only means left height and right height. अब यहाँ पे देखो हाँ ये this is breaking the condition. Okay, because of here you have left having 0 only. Okay, left having 0 only and right having actually height 2. तो 2 minus 0 means false. So ये वाला fluff यहाँ पे actually ये it this becomes false. And whatever you will do actually it makes false only everything. Okay, either call left you couldn't call because of it is null, but for the right you could call, but there is no use of calling right. So here also you can make some optimization, and as told you in previous problem. So for function left call and right call, but left right all are false. True, they might return, not might, yeah, surely they will return true only. But due to first condition, this first condition actually it makes completely false. So here you will return from false means this becomes false. Due to this false only it makes completely right also. There is no use of calculating right actually here. So because here this is true, here true, and surely this will return true only, right will return true only. Okay, so this will return true only. True false true means totally I have false only totally. Okay, so this will return true, false. So this is not balanced, it's still normal. If I had added some here, added some here some in one only one child, then it becomes true because of here right having 2 but left having 1 height, 2 minus 1 becomes 1 only. So it will follow the this condition, then this tree will be balanced tree, okay. But for now this is not balanced. And for this case also, if you see, this is also not balanced because of for right child having 2 height, and but for the left having 0 height. Due to this case actually this is not balanced. If you had added some here some another node, so for the right it is balanced, but for the left you have to check surely left also balanced, then it becomes balanced tree. So this way you could solve this problem, balanced tree problem also, okay. But this is nav approach actually, and because of nav approach time complexity is very high, because of every for every node. For this node you have to visit a whole tree, and for this node also you have to visit all the node, means again same again and again every time you have to visit same node only, okay. That's why it's very becomes very high. Actually, it's like n square. It is like n square complexity. So how I can optimize actually here? First, in nav approach also you could optimize. You don't have to miss visit every node in the tree every time. Okay, if you had found somewhere false, so you don't have to call left right. You could return directly. Yes. Okay, so I think I should not remove here actually. Let's go other tab. सो दूसरा केस हमारा दूसरा तरीका क्या हो सकता है, फंक्शन हम लेते हैं यहाँ पे फंक्शन कॉल। टाइम बहुत ज़्यादा वैसे हो गया है, आई डोंट थिंक आई शुड डू, आई हैव रूट। बट यहाँ पे दूसरे केस में हम क्या करना चाह रहे हैं, जूम करना चाह रहे हैं कि अगर फर्स्ट आई विल डू फ्रॉम द बॉटम ऑफ द ट्री, what I'll do, I'll calculate from the bottom, not from the issue. I'll not do calculate from the top only. I'll calculate from the bottom only. Bottom only means from the bottom. If you see for root, this is balanced only, and you go one step up, and for this node, this left having 1, right having 0, 1 minus 0 means 1. For the bottom again I'm saying for the leaf node, this is because of having left node null and right null, so it means height is 0 only, so it will return 0 height plus 1. This is 0 height having, and but while returning it will add this function will add some 1 value and return here. So left for the left it will return, for the left it will return 1, and but for the right I have 0, so 1 minus 0 it will, I'll do absolute value, so here it will be 1 only, and 1 because of having 1 at this place, and I'll add 1 more and return to up, one step up, okay, in stack call only. So now I'm at the place of 3, and for the 3 right node having 2 no, right having 2, for this case right having 2, right having 2, but left having 1, left having 1. So difference you will calculate same 1 only, and then and because of maximum in the maximum height you have to either left max or right max, okay. In that only you have to add plus 1, okay. You should remember here, because here I had left and right both 0, so 0 plus 1 directly did. But for here this case, right having 0 but left having 1, but I have you have to do max actually, max of left comma right plus 1, that way you have to do, okay. So that's why I returned here 1 plus 1, and here because right having maximum value 2, so 2 plus 1 I'll do, and 3 I'll return 3 from here. So for this node I have right actually having 3 height, right having 3 height. But for the left, if you calculate here, for the right, but for the left you will calculate actually. अब एक चीज़ यहाँ पे करनी पड़ेगी, आप लेफ्ट में आप आए थे जब, यहाँ पे लास्ट में आप आओगे श्योरली, क्योंकि हम यहाँ पे आप यू कुड अंडरस्टैंड लाइक डूइंग प्री ऑर्डर ट्रेवर्जल, नो पोस्ट ऑर्डर ट्रेवर्जल, लेफ्ट right then node, just like you can assume I am doing here for post order traversal like that. Okay, so you have to visit for left, you have to visit for right, then only you're some doing something. Okay, so यहाँ पे आप लास्ट में आ जाओगे, लेफ्ट में आ जाओगे, लेफ्ट आई एम डूइंग बिकॉज ऑफ लेफ्ट हियर, यू हैव टू कैलकुलेट फॉर लेफ्ट, zero only height, 0 plus 1 return from 1 from here, and for the right also return 1. So 1 minus 1 0, and because of this condition is true, so I'll return maximum plus 1, maximum I have 1 only, plus 1 2, return 2 from the right. But from the left actually I have 0, no node. So from the left I have 0. So 2 minus 0 means this is actually false. This making this condition false. So if you had found anywhere false condition, then you have to return minus 1 every time actually. Okay? You have to return minus 1. Because of how you'll identify it, either balanced or not. I can return actually true or false something. True or false I can return. So in this function actually will not, this function will not return true or false. For my this case, this will not return true or false, it will, this will return int only. So it means from the int value only you have to identify either this tree, this tree is balanced tree or not balanced tree. So how I could identify? I could identify if value returned from the child or from the tree is positive or negative. If it is positive, means it's balanced. If it is returning negative, means you could in the function called, like, just like I had some main function, and from the main I had called this function some passing some root, and this will return actually int, it will return some int x. So you have to check if x is greater than 0, means tree is balanced. Okay, otherwise else tree is not balanced. तो इसी प्रकार से आपको ये, बिकॉज ऑफ दिस इज द रूट, आई एम पासिंग रूट एंड रिटर्निंग द पॉजिटिव नेगेटिव, दिस वे ओनली यू हैव टू चेक फॉर एवरी लेवल आल्सो. अब यहाँ पे आप देखोगे, इफ यू सी हियर, यहाँ पे दिस केस, दिस इज रिटर्निंग एक्चुअली what will return minus 1, negative something, some negative value, this will return negative value something minus 1. So you have to check at this place, either left either left child is returning true or sorry, greater than value, or greater than 0 or positive, means positive or negative. So you have to check first, either it's returning positive value or some negative value it is returning. अगर ये नेगेटिव वैल्यू रिटर्न कर रहा था, इट मीन्स यू हैव टू रिटर्न आल्सो नेगेटिव ओनली. क्यों? बिकॉज ऑफ childs, my one of them childs left or right is not balanced, means whole tree is not balanced. Okay, that's why you have to return false only. Okay, this is the basic solution for the optimized case, and this way we could solve actually in order of n complexity only, because every node you are visiting only one times. Okay, so how, yeah, I am writing here some code also, and I'll not solve actually into id system. and I'll provide code into description bar. So here let's I had some tree 1 3 5 something value I had 7 9 10 this way. Okay, so what will be the base condition? Base condition यहाँ पे क्या होगी? If root is equal to null, if root is equal to null, then what will return? I'll return 0 only. Okay, but if root left null, if no, this I'll not check. So now call for the left. Call for the left. Okay. So function root dot left. You have to check here if left height is less than 0. So you have to return actually directly return -1 only. Okay. And if right height you have returned, but can I check here for left right? No, I can check. Okay, so root dot right, and here also you have to check some condition. If right height is less than 0, means you have to return -1. Okay, otherwise you have to calculate some flag. This is you can check here. This is actually simply post order type version only. Here you in the tell you are doing some calculation. Flag, if flag is equal to math dot apps left height comma minus sorry minus right height plus okay left height right height sorry math app से left height minus right height I did, and अगर if left height and right height का difference है if it is less or equal to 1, if it's less or equal to 1, then some true or false will return here, and you can make some optimization also here. If flag if flag is not flag is false, अगर flag हमारा ये false आ रहा it means you can return here -1. Otherwise else के case में in the case of else what will do here you have to return you have to return and maximum you have to find out the max value actually. So math dot max left height comma right height plus 1. Okay, this way you can solve the problem. This is the optimization case है. Every places I have optimized here. अब यहाँ पे हम कर सकते हैं I can do here try and run something. Let's create another one tree, this type of tree. Okay, so I have some here tree left, I have some right, and for the right I have only right node, and this node I have. For the left I have right node and left two node. This way, let's assume I have this type of tree. So and other I'll add here also. Okay, if you check here at this place, because root is not null, so it means calling left child. I have to put some values also here. 1, 3, 4, 2, 7, 9, 11, 11, 5, 12. Okay, this way. So because of function root dot left, I'll do here. So it means first in the beginning I had some function one calling, and again I'm calling for the left height. Because of for left height I am calling left function. Left function means function with three value, and let's call for function with three value. मुझे कुछ ऐसा करना चाहिए क्योंकि लेफ्ट से कंडीशन फॉल्स हो जाए, क्योंकि ये बहुत तुरंत ब्रेक हो जाएगा यहीं से. If you see here, left height is will return because of function 3 will return left height, return -1 actually. Okay, let's do first. No problem. So function call with 3 value comes here again. Root because of 3 is not null. So again I'll call for left height is equal to left height root dot left. While you are doing root dot left means calling function with null. It means it will return 0 only. For left height I have 0 only, but again because of it is 0 not less than 0, so I could call right for the right height also. For the right height function, for the right means for the 2. So again calling function for the 2, 2 having left child surely. So because of 2 having left child, so function ls is equal to function calling with 1, and because of 1, okay, no problem. For 1 while I call I can अ, थोड़ा सा कोड, क्योंकि लाइन ज़्यादा लिखना नहीं चाहता मैं, इसको यहीं पे इवैल्यूएट कर ले रहा हूँ. ठीक है. सो 1 आप जब भी कॉल करोगे तो 1 के साथ में रूट नॉट नल you will call for the left because of left, and right also null actually, so it will return surely 0 plus 1 only. Okay, I'll call, no problem, I'll do. So it will call for the function with value 1, and for the 1 you have to calculate left child here, left height. For the left child surely with passing null return 0 only, not it's not greater than, it's not greater than less than 0 actually. So call for the right also return 0 only, right height also return 0 only. This is also not less than 0. So let's do left height minus right height is less equal to 1. No, because 0 minus 0 I'll do, it comes 0 only. Flag not flag less equal to 0, less equal to 1. Less equal to 1 means it is 0. It is true only. Less equal to 1 true. True makes it false. So return left height right height plus 1. So मैक्सिमम क्या है, 0 ही है. तो हम प्लस 1 करके रिटर्न कर देंगे. यहाँ से क्या रिटर्न करेंगे, रिटर्न करेंगे 0 प्लस 1 करके, तो इट विल रिटर्न 1 ओनली. यहाँ पे आपको 1 रिटर्न हो जाएगा. इट मीन्स नाउ यू हैव टू डू फॉर राइट हाइट. क्यों हम राइट हाइट कर रहे हैं, क्योंकि ये लेस देन 1 नहीं है, लेस देन 0 नहीं है. ठीक है. बिकॉज ऑफ इट नॉट लेस देन 0, इट मीन्स माई डूइंग -1, नॉट आई एम नॉट डूइंग रिटर्निंग -1, डूइंग राइट हाइट. बिकॉज ऑफ फॉर 1 यहाँ पे 1 2 के 1, यहाँ 2 फंक्शन कॉल था ना, राइट 5 के लिए करोगे तो 5 भी 1 ही रिटर्न करेगा। अब इसको थोड़ा हम ऑप्टिमाइज कर रहे हैं, ठीक। यू विल डू फंक्शन कॉल फॉर 5, इट आल्सो रिटर्न 1 ओनली। तो यहाँ पे 1 रिटर्न होगा, यहाँ पे भी 1 रिटर्न होगा। तो मैथ कैलकुलेशन के थ्रू इफ यू चेक हियर, यू हैव टू चेक हियर लेफ्ट माइनस राइट, यानी कि 1 - 1 0 बिकम्स लेस इक्वल टू 0, कंडीशन ट्रू। रिटर्निंग लेफ्ट हाइट, लेफ्ट और राइट में मैक्सिमम कौन सा है, 1 ओनली, एंड 1 + 1 रिटर्निंग यानी कि ट्रू। यहाँ से इस, यहाँ पे एक्चुअली यू हैव टू रिटर्न 1 + 1 यानी कि 2। तो यहाँ से 2 आएगा, यानी कि राइट हाइट में 2 आ जाएगा, ठीक है। अब इस केस, यहाँ इस जगह पे देखो, इफ यू सी हियर in this place, so left height I have 0, right height 2, right height 2 is not less than 0, it means I have to calculate here f, say left height minus right height minus, it means left height having 0 minus 2, absolute value becomes 2 only, so it's not less equal to 1, means condition is false. So from here you will return -1. What will you return? -1 means here, from here I have to return -1 actually, and due to this -1, left height, because of left height returning -1, left height returning -1 less than 0, it means you are returning directly here, from here -1, and you don't have to calculate up now right child. For the one you don't have to calculate right child, because in the left child, from the left child I had evaluated everything, either it's balanced or not. Because of this node it's not balanced tree, that's why I'm returning directly -1. So it is, I think I've written everything properly. I So you can write using this code, otherwise I'll provide in description also. Thank you guys, मिलते हैं नेक्स्ट लेक्चर में। अगर अच्छा लगा हो लाइक शेयर सब्सक्राइब जरूर करें, और ऐसे ही हम अच्छी अच्छी प्रॉब्लम लाते रहेंगे। ट्री बहुत इंपॉर्टेंट है और बहुत इंटरेस्टिंग भी है, ठीक है। नेक्स्ट टॉपिक बहुत इंपॉर्टेंट होने वाला है, आप जरूर देखें उसको। थैंक यू, बाय।